All right. So we have to learn how to derive the OISC estimators. We know that beta 1 is equal to the summation of, xy minus n, x bar, y bar, all over the summation of x squared minus n x bar squared, right? Which is same as the summation of the deviation, that is x minus x bar times the y minus y bar, all that divided by the summation of x minus x bar, you square that. That is how you find that. And again, we said that beta naught is given as y bar minus beta 1, beta 1 times the x bar. Okay, these are called the estimators. But the question of the day is that the people who were coming up with these estimators, how did they reach onto these conclusions? How did they get to know that beta 1 is equal to that, or beta naught is equal to that?
Are you there?
All right. Are you following?
No, you had the gone. You had the.
Oh, okay. Okay. So basically, how were they coming up with these formulas? That's the question of the day. How did they get to know that this is equal to that? How did they reach here? Okay. So you will be interested to learn that actually all these estimators, they came from the simple equation. Y is equal to beta naught plus beta 1 x plus the error term. You remember this simple linear regression model, right? It's the simple linear regression model. So when you solve the simple linear regression model, you come up with what? With those estimators that I showed you. So how do you derive those estimators that I have just shown you? So what happens is that, as I just indicated last time, this error term represents the deviations, okay, or the variances that occur, especially in this same model specification. So the idea is that you try to minimize those variances, those errors and deviations that occur in the model. Okay, there are deviations of the individual scores from the mean or from the expected value. They deviate. So you have to reduce those errors. The idea is that you have to reduce those errors. So in short, we are looking for the values of beta 1 and beta naught that minimizes the error term. So what you are minimizing the error term, of which this error term is actually equal to y minus y hat. Okay, y minus, not y bar, but y hat, where y hat, this y hat is equal to those estimations that you get beta naught plus beta 1 times x. What you get from here is what is called the y hat. So basically, this is what you get. So the y hat, okay, the y hat, these are the estimations that you get. So the deviation of the estimations that you get from the dependent variable y is what you are solving for. So you need to reduce those deviations. And these deviations actually are equal to the error term squared, the error term. So what you do actually to start with, you make the error term the subject of the what? The subject of the formula. You know that when you make the error term the subject of the formula, you shall have y, okay, minus beta naught minus beta 1 x, right? This is what we're going to have, isn't it?
Yes.
Hello? These
Yes.
have just crossed the equal sign, they've gone to the other side of the equation. And so from there, what you have to understand is that these errors, they occur at each independent variable. So they are summed up. We have what is called the summation of what? These errors. So these errors, they are summed together and squared. The deviations are always squared. When you're finding the variance, you're always squaring the deviations. So you can square this side and you square both sides like that. And now let's say, let the squared variances equal to L, right? The squared error term or squared stochastic variable equal to L. Let's just say that, okay? Which means here where there is the error term, we are going to put what? L. Let's say L is equal to that. Let's just say that, okay? Then from here now, we are going to use the calculus. We're going to use calculus to differentiate this equation with respect to number one, beta naught, and also with respect to what? To beta one. Is that clear? You differentiate this equation with respect to number one, beta naught, then you shall differentiate it with respect to beta one. Okay? So how do we differentiate this? From the basics of chain rule that we learned those days back then. We can start by differentiating, these are partial derivatives. Anyway. You can start with deriving this entire equation with respect to beta naught. If you are deriving this equation with respect to beta naught, it shall be dl d what? D beta naught, right? That simply means you are differentiating this equation with respect to beta naught. According to chain rule, you have to drop this number here, the power, and keep what is inside the parentheses the same. Remember, these are summations, as I did indicate, like the errors are summed together. So 2, the summation of y minus beta naught, right? Minus beta 1 x like that. And that is closed, okay? You keep what is inside the parentheses in the same way, and then you multiply by the differential, okay? The derivative of the variable under question. You're deriving this equation according to, with respect to beta naught, right? When you differentiate this equation according to beta naught, you get the coefficient here. You just remain with the coefficient, right? Just remain with the coefficient, which is -1. So you have -1, all that equal to 0. Is that clear? Or it sounds so strange?
Could we go through?
Okay.
Could we go
Yeah.
through? Yes.
Okay. So what happens is that I think those days when you are learning calculus, you learned that if you are differentiating, for example, y is equal to x, you are differentiating x. What you just get is what? Is the coefficient, isn't it? Using the power rule. You just get the coefficient here, which will be 1, right? If you are differentiating 2x, the answer will become 2, right? Yeah, those are basics of power rule. So when you are differentiating this negative beta naught, it becomes -1, isn't it? Right? You just get the coefficient. The coefficient is -1. So basically, that's the same approach that we are using here. So you have differentiated this equation with number 1. Remember now we have just differentiated it with respect to beta naught. So let's solve this equation. Okay, differentiated with the respect to beta naught. What do we do next? So we know that this, since we are multiplying, this -1 can still be this side. It's multiplication, right? So you can have -2, the summation of n times y minus beta naught minus beta 1 x like that. You close all that equal to what? To 0. Do you all agree with me that that's what is there, right? Like -1 times 2 is -2. That's what we have done. But what is inside the parentheses is the same. These are summations with respect to any terms, any terms. This n remains, simply means that you are summing up the expression with respect like to any terms, like any terms. Yes, that's what n means. It doesn't really mean a lot. Clear?
Yes.
Basa, you will speak slowly today so that people understand. And you will be slow. So from here, what do? We divide both sides by -2, both sides of the equation by -2, yeah? When you do that, you have the summation of n, right? Y minus what? Beta naught minus beta 1 x, like that, equal to what? Equal to 0, isn't it? Chi 0 divided by -2 is 0. Is that clear?
Yes, please. Yes, it is.
Okay. So from here now, what do you do next? You distribute this summation symbol, okay? We are distributing the summation symbol. Let's distribute the summation symbol throughout. So we have the summation of n y minus the summation of what? N beta naught minus the summation of what? N beta 1 x, all that equal to 0. Is that clear? We just distributed. Clear up to that edge?
Yes. Yes.
Okay. But what you have to learn from here, you understand that the summation of y variables, okay, divided by n is equal to the mean, right? It's y bar. So now, since you are summing up, like you are multiplying, this summation is also multiplying by the n terms, the summation of n y shall be equal to n y bar, okay? You can just get this. Or the summation of n x shall be equal to n x bar, okay? That will help us even in the long run where we're going. Get these, very, very important, these two. You've gotten it?
Yes.
Okay. If you have gotten this one, so what happens now from here, we know that now when you sum this will be n y bar, right? This one minus will be n beta naught, right? Then minus what? N beta 1 x. Now this part, very, very interesting. This one is just as good as the summation, this part, summation of n x, all right? I say this is equal to n x bar, right? So which simply means that when you have distributed throughout, you have x what? X bar here, that equal to 0. Maybe you're getting confused a bit. What you have done here, you can factorize the beta 1 constant, right? Just to make you understand. We can say beta 1 constant, the summation of what? X. You're following, eh? N. So you can say beta 1 constant, the summation of nx, I say this, nx bar, isn't it? right? The summation of nx is nx bar. So it simply means that you can, since this is multiplication, it is as good as saying n beta 1x bar, right? Multiplication is commutative under the card laws. We learned that the multiplication is commutative, which means you can say 2 times 3, that can give you the same answer as 3 times 2, right? So that's why we interchange this. It's still the same thing, like it's multiplication. Is that clear?
Yes.
I was just trying to prove how we reached here, like that's what we mean, so that you're not just memorizing. If you have observed clearly from here, you can see that everywhere you have n, right? You have n everywhere. So you can divide through by what? By n. When you divide through by n everywhere, this n will cancel, that n will cancel, that n will cancel. You remain with y bar minus beta naught minus beta 1 x bar equal to 0. I'm sure you are seeing that we are approaching where we are going, right? We're almost getting there. Have you seen that? Any question there? Okay. So from here, we can now move on. And as we move on, just hoping that this class is being recorded. You can do all the mouse, but you have not recorded. Okay, it is being recorded. Good.
It's recorded. Yeah.
Okay. So from there, this means that we have y bar minus beta naught minus beta 1 x bar equal to 0. Is that clear? I've just repeated, rewrite what I had down here. When we reach here, you suffer not. You make beta naught the subject of the formula, isn't it? You're just making the beta naught the subject of the formula. How do you do it? Let it cross the equal sign to the other side. So you have beta naught equal to what? Y bar minus beta 1 x bar. And this is the first equation, as equation 1. This is the first estimator. You remember that when I started the presentation, I said beta naught is equal to y bar minus beta 1 x bar. Now we are proving to you that that is true. They were not just dreaming, right? They were using calculus and chain rule to be specific. That's how they reached to this one. Happy?
Okay, go on. I'm going to go on.
No,
please.
you can ask. You can ask. I'm rushing for nothing. Like you can just ask. From now, if you don't understand this one, it means that even when I bring you to Stata to use computers, you will be very blank. You have to understand now. Then when we start using computers, it will be easier. You'll be able to connect the dots.
Okay.
Ask.
Okay, I'm going to ask, maybe can we just go through that once more time, huh? This is this one the one that you call that this one is a fitted model?
Sorry?
The fitted model, is this the one that you call the?
Yes, this is the same one. We are driving those. Yes, for the fitted model, we are getting in the fitted model, there is y is equal to beta naught plus beta 1 x plus the error, right?
X.
Yeah, but yes. there are these are numbers. I think that's what I said in my introduction. Like there are numbers here. So now today we are showing you how to get what formulas do you use to get these numbers. So to find beta naught, we have said is to find the mean of y minus the beta 1 times the mean of x variables. When you compute that, you find the beta naught. That's the number you put here. Even for beta 1, I'll show you how to find that number you put here. And then the model will come out, it will be fitted. Like pa, yachoka fitted line.
Oh. Okay. So I think I'm a little bit okay, I'm getting there. Okay, so let's write down this one. Huh?
This is basically the formula that you use to find the beta 1. Remember in the fitted model, there is beta naught, right? this is the formula now that you use to find the beta naught. By the way, the word estimator simply means the formula that you use to find those estimates. So beta naught is this is the formula that you use to find beta naught. It's y bar minus beta 1 x bar. If you can't remember everything, at least you can remember the formula. Remember the formula.
Yes.
But that's
so
this is
this
how they looked at the formula.
Okay. Which is also known as the true model, huh?
Yes.
I think I'm confusing that. Oh, okay.
You're getting there. Don't worry, you will get there. Any question?
Okay.
So we have learned how to find the beta naught, right? Now we have to show you how the formula, we are deriving the formula for finding beta 1 now. How to find the formula for beta 1. Okay?
Okay. So, okay, let me not preempt.
No, you can ask.
No. Go, let's go. Let's do first.
Yes. So we go back now and have the equation. We said L is equal to Y minus what? Minus beta naught. We have gone back again. Minus beta 1x, right?
Beta 1.
Yes. Where we said the L is equal to the error term squared. That's where we left it. So now we are differentiating this equation with respect to beta 1 now. Previously, we were differentiating it with respect to beta naught, right? So have the L, the beta 1 is equal to. Is that clear? The L, the beta 1 simply means we are differentiating this with respect to beta 1. You know, I like it when I start deriving like this because it's coming closer to where I like it. It will be getting interesting. And you like it when you go to the computers and you know that you have learned econometrics. Yes, we want to teach you real econometrics so that even when you start researching, you're not suffering. You don't even need to suffer in researching. We want to make the conversation that detailed as a specialist of these things. So you drop the 2 as usual. You are using chain rule and with the principles of chain rule, you drop the 2 y minus beta naught minus beta 1 x. Now you're differentiating this negative beta 1x. This is what you're differentiating. Since you are differentiating this, you remain with the negative x, isn't it?
Yes. Just a quick one.
Yes.
In this equation that we are doing, where is the error term now?
The error term, like we made you remember when we solved, we made the error term first the subject of the formula. That is the one that we are minimizing. We are minimizing the errors in the model. So we are looking for the values of beta naught and beta 1. That minimizes the error term to minimize those variances.
Okay.
That's what we are doing. So to do that, we use calculus. That's what we are trying now. We are trying to find those, the estimators that minimize the error term so that the model can have at least some representation which is closer to the true value. Okay?
Okay.
Great. So from here, we have negative x, right? Equal to 0. When you differentiate beta 1, it is equal to negative what? 1, right? Negative beta 1. It's negative 1, isn't it? I'm just trying to remind you. I want you to understand where this x is. Now, this negative 1 times this x, that's negative x. Okay?
Sorry. Which the negative x minus the?
This negative
like minus
beta
the
1.
X.
If it is differentiated, you get negative 1, right?
Yes.
It means that here now you have negative 1. Now negative 1 times x, that's negative x. Okay?
Negative x. Okay.
Yes. So basically, these are basics of calculus, like to be specific, the chain rule. Yeah. Those things. The assumption is that you did calculus and you understood. But if you don't remember, don't worry much. Just get it like this. So from here, you know that you can have negative 2. The summation of n variable y minus beta naught minus beta 1 x times x, right, is equal to 0. We have just gotten negative, like negative 1 times the, 2 is negative 2, right? This negative 1 here, there is 1 here, negative times 2. The way how we did it previous, we are multiplying. So you can divide it through by negative 2 by negative what? 2, like that. This is what we get. Those answers that I wrote as the values of finding beta 1, that is what we are going to find, and see how we are going. We are moving slowly, but we'll get there. Okay? So have the summation of n times y minus beta naught, right? Minus beta 1 x times what? X equal to 0. Is that clear?
Yeah. Yes.
Then from here, what do? We distribute what? We distribute x, isn't it? So have the summation of n times yx, x times y is yx, x times negative beta naught to be negative beta naught x minus beta 1 x squared, right? That is equal to 0. Yes. You are agreeing with me up to this far?
Yes.
Clear?
Yes, please.
And so from here, we understand better. We understand it better that we can easily now distribute the what? This summation symbol. And so we'll have n, the summation of yx, right? Negative, we open the bracket. Negative, the summation of, we open the bracket. What is beta naught? Beta naught, we say this y bar minus beta 1 x bar, we close, we have x, right? Minus the summation of n beta 1 x squared, all that equal to 0. Are you agreeing with me? We just replaced beta naught with the value of beta naught. You remember what we just said previously? You remember? We said beta naught is equal to y bar minus beta 1 x bar, right?
Yes.
Yes, that's what we are done. We are doing right. So from here, what do? We can have n, the summation of yx, okay, then minus the summation of this x. You've seen this x, right? This x, it has to be distributed here. X times y bar, it shall be y bar x, right? Are you agreeing with me?
Wait, which x did you pick up?
This one, this x.
The one in the last equation? Okay.
Yes. And so we can say x again times negative beta 1x bar x, right? You have distributed it inside the bracket. Minus the summation of n beta 1 x squared equal to 0. Clear?
Yes.
So from here now, it becomes that easy. You see that this negative is for both up to here. So you have to distribute it. So you have n, the summation of yx minus y bar, the summation of x, because this is multiplication, plus, okay, plus beta 1 x bar, these are constants. The summation of x minus c, there's n of course, the summation of n beta 1 x squared, all that equal to 0. Did you see it? No, you need time to see it. Let me allow you to look at it. You have seen it, right? This y, check here. I'm willing to make you understand. This y is a constant. We have just put it outside the summation symbol. Like summation y bar x. This is multiplication. I told you we can, under multiplication, we can exchange the numbers in any order. You still get the same answer. So it's the same as y bar, the summation of x, isn't it?
Okay.
Right? That's what we said. So that is what is happening. And similar, even there, even here is what is still happening. So there is summation symbol and you are summing up just like that. Okay? Now, when you reach from here, what do? You make beta. You've seen now that almost all these have got beta 1, right? You make beta 1 the subject of the what? Of the formula. So you have n, the summation of yx minus c, here, where there is summation of x, n. What did I say? I said it is equal to n x bar, right? That's what I said the previous. You agree with me, right? This part. Do you agree with me that that's what I said previous? Hello.
Yes, we're here. Yes.
So you have n y bar x what? X bar, like that, is equal to. We are getting these numbers now. Cross the equation to the other side of the equation, right? To the other side of the equation, there is 0. So when this part, which is negative, crosses the equal sign, it will be positive, right? It will be positive. Summation of n beta 1 x squared, right? Then even this side will cross the equal sign to the other side of the equation. Now, when this side, remember here, you've seen this. This is just the same as this, isn't it?
Yes, it is.
Yes. So it will cross the equal sign, it will be negative beta 1 x bar, then n x bar, isn't it? Like this part has become n x bar, so it has crossed the sign like that. Okay? Are you following? People are following Wasa, and they are understanding. So n summation of yx minus n y bar x bar is equal to, we can factorize what? We can factorize beta 1 now. Kyle is common, right? We can now factorize beta 1 because it's common. So beta 1, then we open the bracket. We'll remain with the summation of x squared, isn't it? We'll remain with the summation of x squared, right? Here, minus n x bar squared. There are 2 x bars. This time is that it will be x bar squared, isn't it? Do you agree with me? So from here, very easy. You can divide it through by what? By this side, which is in the bracket. This part, which is in the bracket. Both sides, so that you can have beta 1. So divide through by summation of x squared minus n x bar squared, both sides. The summation of n x squared minus n x bar squared. And then what do? You cancel these, right? They are dividing, so that beta 1 can become equal to what? The summation of yx minus n y bar x bar over the summation of what? X squared minus n x bar squared, which is exactly what I wrote when we started, isn't it? This is exactly what I wrote when we started. I said beta 1 is equal to that. Do you remember that? We have reached.
That's good.
So we have derived, we have shown. Yeah, I should write it here on top where it should be clear. Beta 1 is equal to the summation of n yx minus n y bar x bar over what? The summation of n x squared minus n x bar squared. Yes, that is what I said. So we have reached. That is the formula. In short, this is the formula that you use to find what? To find beta 1, okay? Then it is also same as the summation of x minus x bar times y minus y bar. These are basically the deviations divided by the summation of what? Divided by the variance, which is x minus x bar squared, the variance of x squared. This is still the other way of looking at it. You can easily get beta 1 when you solve like that. Clear?